Let's look at the NOT operation. The NOT is one of the three basic logic operations, and, or, and not. The NOT operation is, you could say it's your simplest one. So a NOT is just an inverter. It means that one input comes in and the input that goes out is the inverse of the input that went in. So if 0 goes in, 1 goes out. If 1 goes in, 0 goes out. That's all there is to it. So let's write the NOT Boolean expression. Let's write the NOT truth table. And let's write the NOT logic gate. So when we're doing drawings and we're showing that there is an inverse logic gate, an inverter or a NOT gate, this inverter looks like this. It is a triangle and there's a big dot on the end of the triangle. You have to write that dot there. And that's output X. And there's only one input always, input A. So it's pretty simple that way. The Boolean expression just looks like this. The output X is equal to the input A inverted. So that's one way we can write it. The other way we can write it is X is equal to the input A inverted. So these two things mean exactly the same thing. So this is read as X equals not A, or X equals the inverse of A. Okay? So here, X is equal to A inverted, or X is equal to A inverted. When we're typing, it's easier to use this format. When we're handwriting, it's easier to use this format. And in this course, I'm going to use both, and I need you to know the difference. I need you to know both of them. So our truth table is going to be simple. There's only one input. So 2 to the exponent 1 is just 2. So the input is A, the output is X. There are two combinations. A could be 0 or A could be 1. And if the input A is 0, then the output must be the opposite or the inverse of the input, which is 1. If the input is 1, then the output must be 0. So this is, as you can see, an inverter. So I'm going to write this is an inverter. And there are many situations where you need to take a signal, a digital signal, and invert it to the opposite of that digital signal.